Hello, my name is Pruthviraja. I am a certified data analyst and a software trainer. I have a 7+ years of training and teaching experience in engineering and IT field. And today, I would like to welcome you into the NumPy for Data Science and Machine Learning course. Are you interested to become a data analyst, data scientist, or business analyst? If yes, I appreciate and congratulate for your first step towards an in-demand career in IT and business field. Most of the programming enthusiasts like to code in Python nowadays, and it is a popular and growing programming language. So, if you had chosen Python as your coding language to become a successful professional in technical field of data and big data or machine learning and artificial intelligence, then you must be familiar with the numerical data analysis and visualizations. Pandas helps to analyze and prepare data for visualization. But without NumPy, Pandas suffer to perform fast and best. So, NumPy is an essential tool developed by the Python developers for numerical analysis that supports and motivates other data analysis tools of Python. So, why don't you learn NumPy and become expert in big data analyst in Python? Don't worry, if you wanted to become an expert in any other technical field other than data analysis, machine learning, or artificial intelligence, I assure you will definitely gain some meaningful insights for your career development. Never stop learning the new skills and update yourself. So, are you ready? Then join me. Together we can strengthen our technical and career path. I love to see you in my course enrollment dashboard and congratulate for your right decision to become an expert and demanded technical professional in IT industry. Until then, enjoy learning. Hi, welcome to this training video on download and set up the environment. In order to download NumPy or in general the Python packages and useful libraries to work as a data analyst or data scientist, go to website anaconda.com, then click on Products and then choose the individual edition. Click on the download button. It will move to the downloadable page. Select the particular type based on your system environment. Here I am using Windows 64-bit OS, so I choose 64-bit graphical installer. Click on it to download on your system and then choose the folder where you want to download the software. Once you download the installer, the installation remains simple. It is just like installing the other softwares. For the users other than Windows to know how to install Anaconda on your system, go to Resources and then click on Help on Training. On this page, select the individual edition and then click on Documentation. It will bring you to the another web page with the Anaconda documentation for the individual edition. Now, click on the installation. Then scroll down and then choose the type of the environment you are using. Say for example, Mac OS. So installing on Mac OS. Then you will get the detailed step-by-step explanation on how to install the Anaconda on your Mac system. This is how you can get a help of installation from Anaconda website. Now, let us install the downloaded software on our Windows system. Open the folder where you downloaded the software and then double-click the installer to launch. Click Next and then accept the license agreement. Select and install for just me, unless you are installing for all users, which requires Windows Administrator privilege, and then click Next. Select a destination folder to install Anaconda and click the Next button. Choose whether to add Anaconda to your path environment variable or not. Anaconda community says not to add the Anaconda to the path environment variable, since this can interface with other software. Instead, use Anaconda software by opening Anaconda Navigator or the Anaconda prompt from the start menu. So uncheck the Add Anaconda 3 to my path environment variable and then choose whether to register Anaconda as your default button and then click on Install button. If you want to watch the packages Anaconda is installing, click Show Details. Once the installation is successful, it will ask you to install the additional environment, that is PyChart. Click Next. If you wish to read more about Anaconda Cloud and how to get started with Anaconda, check the boxes Learn more about Anaconda Cloud and Anaconda Individual Edition Tutorial and then click Finish. Once you install the Anaconda on your system, you need to check whether it has installed correctly or not. So, on Windows, click on the Start menu and select Anaconda Navigator. Go to All Apps and then Anaconda and then Anaconda Navigator. Or click on the search icon and then type Anaconda Navigator. Now this is the Anaconda Navigator envelope. If you find the button Launch, it means that Anaconda has installed all these packages to work with. Since we are using Jupyter Notebook as our coding environment, so select the Jupyter Notebook and then click on Launch button. Wait for a moment. By default, the Jupyter Notebook will redirect to the users folder where we have installed the Anaconda software with the local host server. So now, choose the folder where you want to work. Let us choose the desktop and then click on New and then click on Python 3. It will open a notebook with the untitled name. To rename that, click on the untitled and then rename. And in the single cell, type and now to run the code or to run the cell, press Shift and then Enter. That is Shift plus Enter. We got the output. Congratulations on successfully installing the Anaconda distribution of Individual Edition on your system to start working with the NumPy package. Thanks for watching this training video. I invite you to continue the course with the further training videos. Hi, welcome to this training video on how to work with the Jupyter Notebook. We have already seen how to open the Jupyter Notebook using the Anaconda Navigator. By default, the Jupyter dashboard will open in a local directory where we have installed our software. So let us select the directory as desktop and then create a new folder by clicking on the New button. Once the folder is created, you can rename it by selecting it with the checkbox and then click on the rename option. Now click on the test folder. Here click on the New button once again, and this time select Python 3 and then wait for a moment. A new Jupyter Notebook will open with the actual code editing tools. This is the actual Jupyter Notebook to write and run the code. To rename the Jupyter Notebook from Untitled to some other name, click on the Untitled and then rename, say for example, Demo Notebook, and then press Enter. This is actually referred as the file name of the Jupyter Notebook. Below the file name section, we have Notebook menu bar, and below that we have Notebook toolbar. At the top right corner, in between the trusted and the Python 3, we have mode indicator. There are two types of mode indicators: edit mode and command mode. If the cell border color is blue, it is in command mode. If it is in green color, then it is in edit mode. Or if we click on the cell to start writing the code, then it is set to be in the edit mode. Next to the trusted text, the small area is known as the notification area. And if the Python 3 circle is like full mode, it is set to be in the idle mode, means not running any code or not working with any code. If it is like dark mode, it is set to be in busy mode, means it is running or working on some code. Now let us type the simple code by placing our cursor in the cell. And then to run the cell, we have multiple options. Option 1, click on the Run button. Option 2, select the cell from the Notebook menu bar, where you will find several options again. But to run the cell, just I will select the first option, that is Run Cells. Congratulations, we got the output. The other options to run the cell are nothing but using the keyboard shortcuts. Here we have only one cell. To insert a new cell, click on the plus symbol from the Notebook toolbar. We can insert as many cells as we want, and then type the code, that is, then press the combination of Shift plus Enter. It will run the cell and insert a new cell. If there is a cell below the current cell or active cell, it will just move to that cell. Another option to run the cell is the combination of Alt plus Enter. It will run the cell and insert a new cell even if there are cells below the active cell. Let me type the codes to illustrate. And now select the first cell and press Alt plus Enter. Notice that it has inserted a new cell. Now let me create one more code below the last cell. Now select the cell with Hello I am 3 and then press Ctrl plus Enter. It will just run the cell and do not move to the next cell or do not insert a new cell. This is all about running the cell or multiple cells. Now let us see how to insert a cell manually without running a cell. Option 1. Click on the plus symbol to insert a cell or multiple cells at once. You can insert a cell wherever you want. For example, let me insert a cell below the current cell. Option 2. If you want to insert a cell above or below the specified cell or specific cell, you can go to Insert option in the Jupyter toolbar and you can select Insert Cell Above or Insert Cell Below. Option 3. With the keyboard shortcuts, we can insert cell as per our requirements. To insert a cell below or above the active cell, select the cell, say for example, cell with hello, I am 4. And then press escape from the keyboard. And now press A. It will insert a cell above the selected cell. To insert the cell below the active cell, select the cell and then press escape and now press B. It will insert a new cell below the selected cell. Now let us see how to cut, copy and paste the cell. To cut the cell, you can just use the cut symbol. Select the cell that you want to cut and click on cut symbol. And you can paste wherever you want using the paste symbol. For example, let us cut the cell with the print hello I am 3 and paste it below the cell with print hello I am 4. Notice that it will paste the cell below the active cell, but paste inside the another cell just like copying and pasting the text. Select the cell in the edit mode and paste. Here the edit mode is very important. So command mode and using the paste symbol will paste the cut cell below the active cell, whereas selecting the cell in edit mode and using Ctrl+V will paste the code only inside the cell. Suppose if you want to paste the code of one cell into another cell or multiple cells, then use the copy symbol. Say for example, copy the first code by selecting the cell and paste it below the cell. Print hello I am 3 using the paste symbol or Ctrl+V. You can also use Ctrl+C and Ctrl+V to copy and paste the cell, but the cell must be in command. Finally, if you want to copy a portion of the code, you can use the normal copy and paste method, which always works like copying and pasting the text. Now let us see how to move the cell up and down. To move the cell up or down, use the up and down symbols from the Jupyter toolbar. So let us select the cell, print hello I am 3 and move up using the up symbol. And again moving down using the down symbol. You can also use the edit toolbar and select move cell up or move cell down, but it won't move the multiple cells at once. To move the multiple cells at once, first select the cell and then press the Shift key to select the multiple cells above or below the active cell, and then use up or down arrow keys of the toolbar to move up or down. For example, let us select the first 3 cells and move up or down. Select the cell and press the Shift key and then select the multiple cells and then press down arrow key. Fine, you just learned how to move the single or multiple cells at once. Let us see how to split, merge and delete the unwanted cells. To split the cell into 2 or more with the specific code, you can place the cursor at the specific point and then use split option from the edit toolbar. For example, let us combine the 2 cells, print hello I am 3 and print hello I am 4. Now I want to split the cell and separate these 2 print statements. So place the cursor at the second print statement and then use split from the edit toolbar. We have split the cell successfully. This is helpful to split the large code into an multiple codes of our interest. Now, to merge the cell with the above or below the active cell, we can use the merge option from the edit toolbar. Say for example, let us merge the cell which has been split just now and then use the merge cell below. That is, Place the cursor where you want to merge and then use the merge options. Either merge above or merge below the cell. Now let us see how to interrupt the cell or cells using a kernel from the menu bar and also using the symbols from the toolbar. If we want to interrupt the notebook when we have run the wrong cell which runs repeatedly, we can use the dark square symbol from the toolbar. Next to that, we have another restart symbol, which is used to restart the kernel without changing the already ran cells. But if you want to restart the entire notebook with removing all the existing outputs or outputs from the notebook, use dark colored double arrow symbol. So it will restart the entire notebook and run all the cells with new outputs. Alternatively, we can use the kernel actions from the kernel menu bar. It has many options like interrupt, restart, and clear all the output, change the kernel when we have different Python versions. Now let us see some other features of all the menu bar items like file, edit, view, insert, etc. You can also insert an image by selecting the cell, converting it into an markdown type, and selecting the insert image option from the edit menu bar. We can hide the cell, numbers, header section, and the toolbar using the view section of the menu bar. The cell section provides many options to run the cell and change the cell to different types, either code, markdown, or raw MB content. The widget section will provide many options to save, clear, and download the notebook. Finally, the help section of the menu bar will provide many options to get help for the various topics like how to use the keyboard shortcuts, edit the keyboard shortcuts. If you click on the keyboard shortcuts, you can see the keyboard shortcuts, and if you want, you can edit them by clicking on the edit shortcuts as per your requirements. So this offers a convenient way to work with the Jupyter Notebook. Now it is our time to see how to open, save, close, download, and shut down the Jupyter Notebook properly. To open the new empty Jupyter Notebook, you can use New Notebook option from the File section of the menu bar. It will open a new notebook with the untitled name. To open the new dashboard, you can use Open option. It will open the new window with the Jupyter dashboard. Make a copy will copy the notebook codes and open as a new Jupyter Notebook with all the cells copied. Save and checkpoint. We'll save and do the checkpoint for the current status at the current time. The additional changes made to the notebook will not be saved until you save and checkpoint the notebook again. So, if you make any changes and do not want to use these current changes, you can always go back to the last saved checkpoint so that you can omit the unwanted changes to the notebook using revert to last checkpoint. Print preview will show the print preview of the notebook if you have the option to save PDF to print or read the document later. The download option allows us to save the Jupyter Notebook in various formats. Finally, the close and halt will close the Jupyter Notebook safely so that we won't lose any data by accidental interruptions of the system. To open the new file from the system, we cannot use the Jupyter Notebook. Instead, we have to choose the Jupyter dashboard and use the upload option. It will upload any file from the system. To shut down the Jupyter dashboard safely, we need to use quit option of the Jupyter dashboard after closing and halting all the Jupyter notebooks. This will shut down the Jupyter dashboard safely. Suppose if you forget to close and halt the Jupyter notebook, you can safely shut down by selecting the running Jupyter notebook from the running section of the Jupyter dashboard. So it is advised to check whether you have safely closed the Jupyter notebooks or not, and then shut down the Jupyter dashboard using the quit option. The logout option will allow you to log out from the dashboard if the admin has set the token ID to log in the Jupyter dashboard. As for now, let us use the quit option to shut down the Jupyter dashboard safely, as you are working as an individual, so no need to worry about the logout option. Once you quit or shut down the Jupyter Notebook dashboard, you can close the window. This is all about how to work with the Jupyter Notebook. Thanks for watching this training video. I recommend you to continue learning the series of training videos. Hi, welcome to NumPy Initialization tutorial. We have already discussed more on the theoretical aspects of the NumPy. So let us start our journey of learning the NumPy straight away. In order to work with the NumPy, we need to import it. Suppose if we import NumPy as import NumPy, then all submodules and functions in the NumPy module can only be accessed. For example, NumPy.array. If we use from NumPy import all functions will be loaded into the local namespace. For example, import NumPy as np. If we use import NumPy as np, an alias for the namespace will be created. For example, np.array. The first two methods are not advisable because in the first method, we need to type NumPy every time, and it can consume more time when we have to work with a large project. On the other hand, if we use the second method, it may result in overlapping function names, where the latest imported function holds the position in memory. So import the NumPy and the alias of np. Let us look at the latest version of the NumPy using the version module attribute NumPy.__version. It is a standard module to know and set the version of NumPy package. Now, in order to show the performance difference between the NumPy arrays and the Python lists, here I would like to use NumPy array of 1 lakh integers and the equivalent Python list, that is array1 is equal to np.arrange of 1 lakh, array2 is equal to list of arrange of 1 lakh, and then use the percentage time method to know the time taken by the NumPy arrays and Python lists to perform a specific task using for loop. We notice that NumPy-based algorithms are generally 10 to 100 times faster than their pure Python counterpart and use significantly less memory. Suppose if you want to know more on any of the NumPy keywords or topics to get help on writing Python program and using Python module, we can use help command. Say for example, to get the details or help on the for loop, we need to type for. So here is the detail about the for loop. In order to come out from the help command, type quit. I would like to check the details of np.sort method. So let us type np.sort inside the help. Here is the detail about the the np.start method. Again, to know the documentation of NumPy's package, we can import topical documentation from NumPy with the module name doc. Once we import it to our local namespace, use it inside the help command to get the details on NumPy's documentation and how it helps to get the details on each basic topical documentation. Here is the details about the topical documentation. Now let us use the basics inside the help command under the namespace np.doc. Say for example basics. Here is the topical detail about the basics. In order to get a list of modules and submodules which uses a particular keyword, we can use lookup method of NumPy by typing a specific keyword. Say for example arrange. When working with the NumPy, it is not necessary to get the complete details on each and every topic. Rather, we should get a detail on the doctrine of each method or modules or submodules used to prepare, process, and or analyze the data in the form of doctrine and signature of a method or a function available in NumPy or in general Python. To get a simple detail on the method, we can just type a single question mark in front of any package or method. Say for example, np.question mark. Here is the simple detail on the NumPy package. If we use double question mark, we will get a complete detail on package or subpackage or any other module. Say for example, np.range. Double question mark. Here is the detail about a range method. Sometimes when we are familiar with some of the topics and also how to use the method and just wanted to know what it does and the available parameters to work with, we can use shift plus tab instead of single question mark or double question mark. Say for example, np.arrange. Press shift and press tab. Shift plus tab resides the basic doctrine or signature of any method or module. If we use shift plus 2 times tab, it resides some more detail about the method or module or function. If we press shift and press tab 3 times, a tooltip will linger for 10 seconds while the time. Suppose if we press shift and press tab 4 times, it works similar to like typing a question mark in front of the package or module. We can also use tab completion to complete typing the module or keywords or identifiers created. If I just type np dot and then press tab, it displays all the available methods on NumPy. Suppose if I want to type a range, then I can just type a few letters and then press tab to autocomplete or use the available word followed by the typing letters. Say for example np.ar and then use the up or down arrow keys from your keyboard to select one you want and then press enter to apply it. Here I would like to use a range, that is np.arrange, and then press enter. In this tutorial we get to know how to initialize the NumPy, how to get the help on any topic, how to use single question mark and double question mark to get the help without using the help command, how to use tab completion to get the simple and useful details on any topic or module, and also how to use the tab completion to look for the available methods, keywords, and identifiers to work with. Thanks for watching this training video. I request you to continue learning with the series of training videos. Hi, welcome to this training video on creating ND arrays in NumPy. One of the key features of NumPy is its n-dimensional array object, or ND array, which is a fast, flexible container for large datasets in Python. Arrays enable you to perform mathematical operations on whole blocks of data using similar syntax to the equivalent operations between scalar elements. The easiest way to create an array is to use the array function. This concept accepts any sequence like object, including other arrays, and produces a new NumPy array containing the parsed data. The simplest way to create an array is to use a list or nested list. Let us begin with a list which is formed by a range of elements. Printing the list will display it in the same way. Now, create an array of size equal to the list created earlier by passing it inside the array function of NumPy. Now, if I print this array using the print statement, the displaying result varies from that of the list. Here, the arrays are displayed like a list of elements without comma. Make a note of this, as it may be asked in the quiz type of interview questions. We can create a multidimensional arrays using a nested list of elements. For example, lists inside the list. And pass this into the array function. Again, let us see how print statement displays this array now. Once again, we got the same result, that is a multidimensional array elements without a comma. In order to know the dimension of the array we created, we can use n-dimension attribute. Say for example, dot n-dimension. We got the dimension as 1. For array 2, we got the dimension 2. To know the shape of the array, NumPy provides shape attribute. Let us see the shape of the array created. For example, let us create a 3-dimensional array using a nested list of dimension 3. List with multi-list. And then use inside the array function. If we look at the dimension using n-dimension attribute, we got that the dimension is 3, and the shape by using the shape attribute. It shows that the array is of size 3 with the shape 2 cross 2, or 3 arrays of shape 2 cross 2. First array, second array, and third array. These arrays are, that is, the individual arrays are called the lower dimension arrays. Similarly, we can create an array of any shape and dimension. Say for example, let us print the dimension and the shape. To know the type of the data we are using, we can use data type metadata object. Say for example, we have used integer type of data to create an array. So print, let's take array2 dot dtype. The result is of type in 32. And let us see the type used for the array1. Once again, it is of type integer 32. Suppose if we use mixed type of data to create arrays, NumPy by default will cast the type to floating point integers. For example, if we create an array of fixed type values like and if we use this list to create an array like notice that the entire array has been typecasted to the type float. Now if we check the array, we may get a typecasted data type. We can easily create an array of type zeros, ones, and also of type empty. Zeros function creates an array of zeros. If we pass a single value, it just creates a one-dimensional array of zeros. We can pass values to the shape parameter of zeros to create an array of special shape with zeros. Here, the shape is passed in tuple format. For example, pass a tuple as a shape inside the zeros function. For example, 3, 6. Ones function creates an array of ones. For example, here also we can pass a tuple to the shape parameter to create an array of specified shape with all values equal to 1. An empty creates an array without initializing its values to any specific value or a particular value. For example, sometimes, in some cases, it may return uninitialized garbage values. So, choose wisely while creating an array of null values. A range is an array valued version of the built-in Python range function, which is used to create an array of fixed type with a range of values, optionally having the start, stop, and the step size. If we do not specify the step size, it returns evenly spaced values within a given interval. Say for example, let us pass the start and stop values for a range. For example, 10, 20. And let us pass the start, stop, and also the step size. Press Shift and then Tab to see the parameters. As I told earlier, it has start, stop, and step size, and optionally the type of the data. Let us create an identity type of 2D array with the NumPy's I function. It has the n, that is the matrix size, and other parameters. It returns a 2D array with ones on the diagonal and zeros elsewhere. So let us create an identity matrix of size 5 cross 5. Thanks for watching this training video. I recommend you to continue learning with the series of training videos. Hi, welcome to this training video on data types in NumPy. In this video, we'll learn about the types of data, that is, the metadata or the data about the data. And it is a kind of useful information about the data we use. Data types are a source of NumPy's flexibility for interacting with data coming from other systems. In most cases, they provide a mapping directly onto an underlying disk or memory representation, which makes it easy to read and write binary streams of data to disk and also to connect to code written in a low-level language like C or Fortran. Here, the data type is indicated by the type of the data followed by the number, which indicates the number of bits per element. For example, float 64, where the number 64 indicates that it is a 64-bit floating point number. Similarly, other types of data such as int32, int64, etc. Here is a list of data types the NumPy supports for numerical and non-numerical elements. So having said, we can use specific data types. So let me create an arrays with different data types. Let us take or use the data type as float. Press Shift and Tab to see the data type parameter. By default, it is none. Let us replace with float 64. Let us create another array of type integer 32. If we check the data type of the array with the dtype attribute, say for example, we got the result as a type int 32. For array 4, we also got the data type of type int 32. Let us check the data type for the floating point array. So we got the data type of type float. We can easily and explicitly convert or cast one type of data into another type using asType method. For example, let us convert a previously created array, that is array underscore 4 of type int 32 into float 64 and see what happens. AsType np dot float 64. So the integer type of array has been converted into floating point array. Similarly, we can convert floating point array into an integer type array. So for example, dot asType int 32. Sorry. We have successfully converted a floating point array to an integer type of array. Suppose if we cast from floating point type to an integer type, the NumPy's asType will truncate the decimal point of the numbers. For example, let us cast this into an integer type of type int 64. Notice that the decimal point of the floating point numbers has been truncated. If we have an array of strings representing numbers, we can use asType to convert them to a numerical form of arrays. For example, let us convert this into an integer type of int 32. We can also convert the string type integer to a float type without specifying the type of the float. We can also use one data type to convert the data of another type. For example, add a floating point type array as now to convert int underscore array of type integer to a float, we can use data type of float, that is float underscore type dot dtype inside the asType method. We can also use the shorthand type code strings to refer to a data type. For example, unsigned int of integer 64 here U8 is a shorthand for the unsigned integer, that is unsigned 64-bit integer. Similarly, you can work on the other types of data types in NumPy. Thanks for watching this training video. I recommend you to continue learning with a series of training videos. Hi, welcome to this training video on pseudo-random number generation in NumPy. To generate a pseudo-random number, simply termed as random numbers or sample values of various dimensions, NumPy provides random modules with many functions to generate various random numbers. We can directly use the functions without setting them. Let me create a range of random values from the random module with a randn function, that is np.random.randn. If we do not pass any integer value, it will simply generate a single random number. The docstring says it returns a sample or samples from the standard normal distribution. Here d0, d1 and dn are used to represent the size and shape of the random numbers. When we use more than one single integers, the random function will generate arrays of different dimensions. Let us use the shape 2x3 to generate a random numbers from our choice. So in simple, we can say that to generate a random numbers of specific shape, pass the integer numbers of our choice. Here I would like to generate an array of 2 rows and 3 columns. To get an higher dimension array of random numbers, just increase the number of integer of our choice. Say for example, I would like to create a 2 arrays of shape 3 cross 2. That is 2 arrays of shape 3 rows and 2 columns. So I need to pass 2 for 2 arrays and the shape, that is 3 rows and 2 columns. To generate the random numbers from the normal distribution function, use normal function instead of randn along with the size of the array, that is np.random.normal, and then pass the size of the array. Here the size is none by default as per the docstring of the normal function. If we do not pass the size, it will simply generate the one single random number through the normal distribution. In order to avoid using the np.random module always, we can import all the functions from the random module to the local namespace using star. Let us import all the functions from the random module to the local space. From numpy.random import all, and then see module with the seed function, so that all the numbers are going to generate through the deterministic behavior of the module. So let us seed the random function using the seed operator and then generate the random numbers. Let me create a range of samples from a normal distribution with the mean 0 and the standard deviation 1. To generate the samples from the uniform distribution, use rand function. To generate a random integers from a given low to high range, use randint function. If we pass shape to the size parameter of the randint, it returns a random numbers generated within the low and high range up to the size of the shape passed. For example, let me generate a random numbers of size 2 cross 5 between the low and high range. Each random number will be generated number of times the size of the given shape and then displayed to us. So the parameters in the dark string are low, high, and size is none by default. And the default data type is of type integer. So let me create a random numbers with the array shape 2 cross 5 between the low and high range of 10 and 30 respectively. If I try to use or try to reshape, if I try to use reshape on randint, it gives error because I cannot create an multi-dimensional array with a single random number or single random integer value. For example, randint will generate a single random number between the low and high range. So here we got a single random number between the low and high range of 10 and 30 respectively. If I try to reshape using the reshape method, we will get an error. But I can use on randn. So if we want to generate a random numbers or random values of specific shape by ignoring the type of the values, use randn. So let us create an array of 2 cross 5 with the 10 random numbers created by the random function. The data generation function in numpy.random use a global random seed. To avoid global state, we can use numpy.random.random state to create a random number generator isolated from others. So let us create a rand from the random state isolated from others, and then use the other functions similar to like random, and then the function name, that is the rand function. So let me create a random numbers from the rand function, rand.rand, and then randint function to create a random integer sample, and randn function to create a range of random values, and normal function to create a random numbers from the normal distribution, and uniform function to create a random value from the uniform function or uniform distribution. Similarly, we can create a random numbers with multi-dimensional shape and practice well. Thanks for watching this training video. I recommend you to continue learning with a series of training videos. Hi, welcome to this training video on arithmetic operations in ND arrays. Arrays plays an important role in batch operations on data without any loops. In NumPy, we call this type of operation as vectorization. Any arithmetic operations between equal size arrays applies the operation element-wise. So, we shall have a look at this by creating a 2D array. For example, data1 is equal to if we multiply the arrays of equal size, the operation of multiplication takes place element-wise. So here we have an array data1. If we multiply the same array with itself, we got an array of the same size with each element on one array is multiplied with the corresponding element in another array. Similarly, let us perform an addition. Arithmetic operation with the scalar values results an arithmetic operation element-wise. This is termed as a scalar operation. For example, data 1 multiplied by the scalar value of 3. Similarly, let us see the division operation by dividing the scalar value 1 by each element of the array. That is 1 divided by the data. We can also use power operation to power each element of the array element-wise. Let me power each element of the array with 2. To power the array with the scalar value, we need to use two star symbols. One star symbol for multiplication and two star symbols for powering the array or any other integer value. If we compare the same size array, the result is the Boolean type array with data type Boolean. So let me create one more array to compare with the already created array. That is now compare the two array with the conditional logic greater than or equal to or less than or equal to or greater than or less than. Let me display the data 1 first. And then data 1, is it greater than or equal to data 3? Here we got the Boolean array with the Boolean values true or false for each element comparison in each arrays. For example, 12 in data 3 is greater than or equal to 3 in data 1. So we got false. 4 is greater than or equal to 4, so true. All the elements in data 3 in the second row are greater than all the elements in the second row of data 1. But here we are using data 1 is greater than or equal to data 3. So the second row elements of data 1 are not greater than the second row elements of data 3. So obviously we got false for all the elements. I request you to work with the similar type of examples. Thanks for watching this training video. I recommend you to continue learning with a series of training videos. Hi, welcome to this training video on indexing and slicing. Indexing in NumPy is a very important operation to extract and modify the arrays to filter it in the right way. We can easily index and slice one-dimensional arrays as they behave like Python lists. But indexing and slicing multi-dimensional arrays needs some kind of skill. So let us begin with the one-dimensional arrays. Slicing the second element is the value at the third position, because in Python and its ecosystems, the indexing starts from 0, not from 1. The value at the third position is 2. Let us extract the value at the third position. To pass the position as an index value, we need to use the square bracket. Inside the square bracket, pass the position. So we got the value at the third position. that is first, second and third. Slicing the values from a range will result the values within that range, excluding the outer bound. For example, here I would like to slice from 10 to 15. Within the square bracket, pass the integers to slice from 10, 15. Colon is used to represent a range slice. After slicing the values, we got a list of values within the lower and upper bound, excluding the value of the upper bound, that is 15. We can assign the new values for the indexed and sliced values. All the old values will be replaced by the new values assigned. For example, assigning the value 14 to the slicing from 10 to 15 results all the values replaced by the 14, excluding the upper bound. This is commonly referred as broadcasting or scalar propagation. The major distinction or difference between the Python lists and the NumPy array is array slicing in NumPy is a view on the original array. This means the data is not copied and any modifications to the view will be reflected in the source array. For example, let us take the copy of the slice from 10 to 15 as array2. Now, if we assign a new value for the third element of the slice, say for example 30, and if we recall the original array, the array modification will reflect, and the same can be seen here with the value 30. If we use single column in slice without lower and upper bounds, then all the values of the slice are assigned with the new value. This type of slice is known as bare slice. For example, array2 with bare slice will be assigned to the new value 50. And let us display the array1. In the original array, the new values assigned are reflected. In the sliced portion, it has been extracted earlier. For the higher dimensional arrays, we can use many more options. To work with the higher dimensional arrays, let me create a simple two-dimensional array. Say for example, now if we index using the index method, we will get a one-dimensional array instead of a single element. That is a scalar, because in multi-dimensional arrays, the indexing will select the lower dimensional arrays first and then look for the additional indexing position option. So if I index the array 2D with the index integer 1, inside the index notation, we will get a one-dimensional array at index position 1. Now, if I would like to access the third scalar value in that array again, I need to pass an index position of that scalar on the already created index, that is array 2D with the lower dimensional array at position 1 and then access the scalar value 2 to access the value of the third position. Here we got 6. Thus, individual elements can be accessed recursively. The above indexing is equivalent to array 2D inside the square bracket first to access the lower dimensional array first and then the scalar value from that lower dimensional array. Say for example, scalar value or array element at position 2. When we have only a two-dimensional array, this works well. Suppose if we have an array of greater dimension, say for example 3-dimension array, then selecting lower dimensional array is as simple. Say for example, the first lower dimensional array, with the index value 0. Once we select a lower dimensional array, both scalar values and arrays of same size can be assigned to it. To illustrate this, let us copy the lower dimensional array selected just now to the new array called first array. To copy the array, use copy option. Let me assign a scalar value to the first selected array, that is, for example, 60, and display the original array. Now, let us assign back the copied array, which avoids to create a new array of same size to the previously selected array, that is, and display the original array. We can notice that the scalar value assigned has been replaced by the array of same size. We can also use the index notation used to index the 2D array for the multidimensional array also. Say for example, I would like to select a second row of the first lower dimensional array in 3D array, that is, first lower dimensional array and then the second row. So here is the second row of the first lower dimensional array. This is similar to like first selecting the lower dimensional array like and then extracting the second row at index position 1. Slicing can be done with the multidimensional arrays using a familiar syntax. When we want to slice a 3D or greater than 3-dimensional array, first we need to select the lower dimensional array with the basic indexing method and then use slicing mechanic. So let us assume that we are working on a lower dimensional array, say for example a 2D array. Now slicing of an array takes place in two ways, like along the axis 0 and 1, that is, along the row axis and column axis. The first indexing and slicing is done along the row axis and the second indexing and slicing is done along the column axis. So let us slice the first two rows along the row axis, that is, column 2. By mixing integer indexes and slices, we get lower dimensional slices. For example, in order to select the elements of the second column, which are at the column index 1 position, we need to pass index value 1 for the column index, that is, select the first two rows and then select the second column at the position index 1. We can also slice the specific rows and columns, say for example the first two rows and columns from second to end of the column. Since we have only 3 columns in the above array, so we can use one column to slice from the second column, that is, select the two rows, the first two rows and columns from second column to the end of the columns, that is 1 column. We can also select specific row and column values. For example, let us select the second row and the first two column values, that is, second row at index position 1 and first two column values. In order to select the entire rows or column axis array elements, we need to use the base slice for the rows or columns, or for both based on the requirement. For example, let us slice the entire row axis and only the second column values, that is, column and then only the second column using 1 column 2. We can also assign a scalar value to a selected row and column elements. For example, select the first two rows and then columns from second column to the end of the columns and assign a new value, say for example 20. Now let us work with the higher dimensional array, that is 3D array. We already know that indexing a third array, that is three-dimensional array, will first select the lower dimensional array, that is two-dimensional array inside it. That is, if we index with the 0, we will get the first lower dimensional array. Now, to select the first row axis elements of this lower dimensional array, we need to use the recursive indexing notation. That is, indexing on the indexed array. So let us select the first lower dimensional array and then select the first row axis elements. That is, first select the first lower dimensional array and in that array select the first row. Here, the first index select the first lower dimensional array and the second index on this index will select the first row axis element of that lower dimensional array. To select a specific columns and rows of a lower dimensional array, we need to use slicing on the lower dimensional array. Say for example, array 3D of 0 will extract the first lower dimensional array, and slicing on this array will slice the lower dimensional array. That is, select all the rows and columns from second columns to the end of the columns. All the rows and from second column to the end of the columns have been extracted. Similarly, all the rows and the first two columns of the lower dimensional array, that is, all the rows, column, and then first two columns. The alternative simple method to index, slice, and modify the values for the lower dimensional array elements from the higher dimensional arrays is to use the recursive indexing in the form of converting a higher dimensional array into a lower dimensional array. So let us illustrate this by first extracting the second lower dimensional array from the three-dimensional array using the position-based index, that is, y is equal to. Now, to select a first row axis elements was index value 0 onto it, that is, y inside the square bracket 0. Once we have a lower dimensional array, we can further reduce it to another lower dimensional array of our interest, and also we can extract as many lower dimension arrays as we want from the higher dimensional arrays. Just for the illustration, let us select all the rows and the first two columns of the lower dimensional array y, that is, all the rows and the first two columns, column 2. Similarly, you can work with the higher dimensional arrays of dimension greater than 3 and practice well. Thanks for watching this training video. I recommend you to continue learning with a series of training videos. Hi, welcome to this training video on Boolean indexing. Boolean indexing helps us to filter the simple or multi-dimensional arrays. The indexing is based on the label or index check. That means comparing the label or index first yields the Boolean array. After that, using this inside the index method will filter the arrays. Here, the Boolean arrays must have the same size or shape as that of the filtering array. The Boolean array or Boolean indexing is also applied with the integer arrays, but this type of indexing is more popular for non-integer based arrays or data sources, where labels plays an important role in filtering the data sources. Let us illustrate this with the help of the simple example. That is, let us create an array of days: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, Thursday, Thursday. Here, Sunday and Thursday are the repeated days. And also create a multi-dimensional array with the random values using the random function np.random.randn with the shape 10,4. We have created two arrays. Now let us create a Boolean array from the first array, that is from days. Say for example, days is equal to Sunday. If we use this as the index for the second array, that is for data, all the rows are filtered with the true and false statement of the Boolean array. The result will filter the array data where the Boolean array elements is true. So pass days is equal to Sunday inside the indexing method onto the data. If you look at the Boolean array where Sunday is present at the positions 1st and 8, and the corresponding Boolean array with the true statements at the respective positions. Hence, the rows where the Boolean array is true are extracted from the source data. We can also use combination of the Boolean array and the slicing or indexing for the columns and rows. Here in the above example, we used the Boolean array to filter only the rows of the data. If we use integer indexing or slicing at the column, we may get a filtered data with both rows and columns. For example, let us use the Boolean array to filter the rows and integer slicing for the columns from second column to the end of the columns. That is, days is equal to Sunday and columns from second column to the end of the columns. Or we can just select a specific column, for example, the second column. We can also use not equals logical condition to create a Boolean array to filter the arrays. For example, let us filter the data source with the days not equal to Sunday. The above Boolean condition can also be expressed with the negate symbol, that is, negate the condition days is equal to Sunday. Negate the condition which is equivalent to days not equal to Sunday. And pass this inside the index method onto the data to filter the data values where the days is not equal to Sunday. Suppose in future, if we want to change any Boolean condition with respect to the requirement and to maintain the original filter, we can save or assign the Boolean condition to any identifier, and then we can use any element as the conditional element. For example, condition is equal to a Boolean array where days is equal to Sunday, and simply negate the condition to filter the data inside the index method. That is, data inside the square bracket, negate the condition. To filter the data with more than a single element, we can use multiple logical statements with logical and or statements. For example, to select the days with Sunday and Thursday, here I am using the or symbol between each logical statement. That is, days is equal to Sunday or days is equal to Thursday, and then created a multi-conditional statement and use it in the index of the data to filter where the rows corresponds to Sunday and Thursday. As we have discussed earlier, we can also use integer-based logical statement to create a Boolean array. And also we can not only filter the data but also can modify by assigning a new value to the filtered elements. For example, let us filter the data with the array element values less than 0 and assign the value 0 for them. That is, data elements or the row elements where the values is less than 0, and select all the values using the index method and assign 0 for them. Here we got the expected result. Let us illustrate this with another example by filtering the data where the array elements are not equal to Sunday and assign them with the value 0.5. That is, days not equal to Sunday inside the index method and assign the value 0.5. Similarly, you can try working with the Boolean indexing on multi-dimensional arrays. Thanks for watching this training video. I recommend you to continue learning with a series of training videos. Hi, welcome to this training video on fancy indexing in NumPy. Fancy indexing is a simple indexing method. It means passing an array of integers or indexing using integer arrays to access multiple array elements at once. Let us create an array of particular size and shape to illustrate this fancy indexing. Here, first I would like to create an empty array of shape 10^4. And then assign a specific value for each row using for loop. For example, multiply each row indices value with 2 and assign all the elements of the same row. That is, assign that value to all the elements of the same row. Now, let us create a fancy index with the integer arrays. For example, select the rows at the index positions 2, 1, 5, 9 and create a list of indices. And pass this integer array to indexing to access the rows corresponding to these integer arrays from the data. We can also use negative integers to access the rows starting from the last rows, that is, from the last row which corresponds to -1 and decrease from -1 to -n up to the number of rows. Here, for example, select the bottom first, second and fifth rows and pass the list of integers to the indexing method. Please make a note that the negative index starts from -1 in Python and not from -0 or 0. And values also corresponds to the specific index, that is -1 means value from the last, -2 means second value or second row from the last, and so on. Unlike 0 means first value from the first, so negative index follows the natural index which starts from 1 but with a negative sign and from the last or bottom of the array like data. We can also pass multiple index arrays to access the array elements. In this case, a tuple of indices is formed from the combination of each index values from each arrays and the corresponding array elements will be selected from the main data, where we use this multi-index. For example, let us create an array of shape 10^4 with the natural numbers starts from 0 and create a multiple index arrays as a list of index values, that is, list 1 with indices 1, 2 and list 2 with the indices 3, 3. Let us use this list of indices inside the index method. Here, from the two index arrays, the tuple of indices have been created like 1, 3 and 2, 3. That is, 1 from the list 1 and 3 from list 2. Similarly, 2 from list 1 and 3 from list 2, forming a tuple of indices. The index positions in the tuple are like first value refers a row and second value refers a column. So tuple of index 1, 3 means select row at index position 1 and the corresponding column at index position 3. So that is 7. Hence the value at the index second row, fourth column, which is 7, has been selected. Similarly, the other value 11, which is at the third row and at the third position. Let us create another example with 4 tuple of indices formed by an array of indices, that is list 3 and list 4 with a list of integers as 3, 2, 5, 9, 1, 2, 3, 3, forming a tuple of indices 3, 1, 2, 2, 5, 3 and 9, 3. We can directly pass a list of integers to the indexing to select an array elements. For example, pass a list of indices, that is 1, 5, 7, 2, directly onto the index method. We can also create a rectangular region formed by selecting a subset of the matrix rows and columns. For example, first pass a list of integers to select a particular rows like above, and then pass another fancy indexing on this to get a rectangular region, that is, First, a list of indices, that is 1, 5, 7, 2, like above, and then pause, another fancy indexing onto it. So selecting all the rows and only the columns first and 4. That is, the columns at the first and the fourth position. We can rearrange the rows and columns using the fancy indexing. Here is an example. For example, select the rows 1, 5, 7, 2. That is, select the rows at positions, index positions 1, 5, 7, 2. After that, apply a fancy indexing once again on the selected rows. Here, the first column is at first position, the last column is at second position, the second column is at third position, and finally, the third column is at fourth position. Similarly, you can work with the more examples on fancy indexing. Thanks for watching this training video. Let us continue learning with a series of training videos. Hi, welcome to this training video on universal functions. A universal function is a function that performs element-wise operations on data in ND arrays. The universal functions behave as post-vectorized wrappers for simple functions that take one or more scalar values and produce one or more scalar results. To begin with, create an array of range 5. To take out the square root of each array element, use sqrt method, that is the square root method of NumPy. It takes arguments and keyword arguments. To take an exponential of each element, use exponential function, that is np.exponential inside the parenthesis, pause the data. To take out the maximum value in a one-dimensional array like this, use max function, that is np.max. Similarly, use minimum function to get the minimum value of the array. These universal functions, which takes one array as the input, are referred to as unary functions or unary universal functions. We can also apply universal functions on two or more arrays of data using extended form of universal functions and are referred as binary universal functions. Let us see how these binary universal functions works. In order to show how this works, let us create two arrays of same size or shape. Now use maximum function and use these two arrays as the arguments, that is np.maximum, and then pass the data1 and data2 as the arguments. This will compare the two arrays and gives the maximum among the two in each array. For example, the first element in data1 is maximum compared to the first elements in data2. Hence, the first element in data1 is taken as the maximum element or the maximum value. Similarly, the second element in data2 is greater than the second element in data1. Hence, second element in data2 is taken as the maximum value, and so on. Let us create one more array to show the remaining universal functions, that is data3. The mod f universal function will return the fractional and integral parts of the floating point array. Here I have created a floating point array. Let us use the mod function on this array, that is np.mod, and then separate the fractional and integral part by using the identifiers fraction, integral. Let us check the fraction part and then the integral part. If we try to take out the square root of this floating point array, sqrt function may return nan for the negative values and gives warning for us. Let us see what is the warning. Invalid value encoded in sqrt method. Suppose if I convert the negative values into positive values using the absolute function, that means by using the absolute function if we convert all the elements of the data tree into an absolute values, we can use the square root method on these array values. Since we have converted all the array elements into positive values, so we won't get any error or the warning message. The square function similarly returns square of each element. If the number consists of more zeros after the decimal point, negative power is used to represent the decimal distance of that value. The rint function will round off the floating point value to an integer value by keeping the negative sign unchanged. In other words, it rounds elements to the nearest integer, preserving the data type. The ceil function computes the ceiling of each element, that is, the smallest integer greater than or equal to that number. Let me display the data first and then use the ceil function. Now let us see how we can use arithmetic universal functions to add, subtract, multiply, power and divide the arrays. So let me create two arrays of same shape first, that is data4 and data5. The add universal function will add the two arrays element-wise. The subtract universal function will subtract the arrays element-wise. Here, in the subtract method, the second array elements are subtracted from the first array elements. That is, data4 array elements are subtracted from the data5 array elements. The multiply universal function will multiply each element of one array with the corresponding element of the another array at the same index position, element-wise. This is the major difference between the dot product and the multiply functions, where dot product performs matrix type multiplication, whereas multiply will multiply each element of one array with another array of the same type. So no need to transpose rows into columns unlike the dot product. So let us multiply data4 array elements element-wise with the data5 array elements. Similar to like multiply, divide universal function divides the first array elements by the second array elements, element-wise, instead of the Python traditional floor division. This returns a true division. True division adjusts the output type to present the best answer regardless of the input types. The power universal function will power the first array elements using the second array element as the powering integer. In simple, it raises elements in first array to powers indicated in the second array. So let us raise the elements in data4 with the powers indicated in the array elements of data5. The greater universal function will return the Boolean array indicating whether all the elements in the first array are greater than the second array. If first array elements are greater than the second array, then results true, else false. Let us check with the above two arrays. Let me display the two arrays first and then use the greater function. Here the data4, that means the array data4 is not greater than the array data5. Hence it results false. If we interchange the arrays, that is data5 and data4, we will get true because data5 array is greater than the data4 array. Similarly, we can apply the universal functions to an higher dimensional arrays and practice well. Thanks for watching this training video. I recommend you to continue with the series of training videos. Hi, welcome to this training video on conditional logics in NumPy arrays. We know how to use the basic if-else statement as a conditional logic in programming. The same if-else statement can be used in slightly different way. That is, like execute the expression x if condition is true else execute the expression y. Let me create two arrays to show how we can use the if-else statement, data x and data y, and then create a condition to use as the logical condition with the Boolean elements true and false. In the logical condition, we have true at the 0th position, false, false at the first and second integer positions, and true, true at the 4th and 5th integer positions. Now, let us take the values from the array data underscore x if the corresponding value in the condition is true. Else, take the value from the data underscore y. In order to achieve this, we can use the least comprehension method with the Jupyter data. So let us create an conditional logic using the if-else statement. X if c else y for x, c, y in the Jupyter data of data underscore x condition and data underscore y. This has multiple problems. First, it will not be very fast for large arrays because all the work is being done in interpreted Python code. In second, it will not work with the multidimensional arrays. So, where function of NumPy is most useful to work with the large size and multidimensional arrays. The second and third arguments to np.where don't need to be arrays. One or both of them can be scalars. A typical use of where in data analysis is to produce a new array of values based on the another array. Let me illustrate the above same example with the where function, that is np.where. Take out the element from the data underscore x if the condition is true, else from the data underscore y. If you look at the signature, you can easily guess the three parameters in the order condition x, y. It returns the elements chosen from x or y depending on the condition. If you interchange the data underscore y and data underscore x, you may get the data for y instead of x. Here, the above statement can be treated as take values from data x. If the condition is true, else take from data underscore y. Let us look at the second array at where function. For example, data underscore z. Here, it is a two-dimensional array. Now, I would like to substitute plus 5 if the elements of the above array are greater than 0, else minus 5. That is, condition data underscore z greater than 0. That means elements of the data underscore z, if they are greater than 0, then substitute 5, else minus 5. Suppose if I want to keep the same data elements, if the condition becomes false, I can use the original data instead of minus 5. That is, if data underscore z is greater than 0, substitute 5, else keep the same elements. Similarly, you can use the where function for the multidimensional arrays and practice well. Thanks for watching this training video. I recommend you to continue with the series of training videos. Hi, welcome to this training video on mathematical and statistical methods in NumPy. NumPy allows us to assess the mathematical functions as the methods of the array class to compute the statistics on entire array and also along an axis if the array is of multidimensional array. To illustrate this, let us create an array of shape 6, 3, that is 6 cross 3, 6 rows and 3 columns. Now let us apply some statistical functions like mean, minimum, maximum, and some arithmetical functions like sum, cumulative sum, etc. Here I would like to start with the mean. to see the mean of the entire array, that is data.mean, and minimum to see the minimum value of the entire array, maximum to see the maximum value of the entire array, sum without parameter change to find the total sum of all the elements of the array. Because sum uses the axis as the first parameter. By default, it is none, and data type as the second parameter. It also accepts the condition. So, the sum function returns the sum of the array elements over the given axis. So let us find the sum of the elements along a particular axis, like along the rows and columns. Axis is equal to 0 refers along the row axis, and axis is equal to 1 refers along the column axis. Here carefully observe the words along the row axis and along the column axis. Along row axis means go from top row element to bottom row element and find the total sum. So we will get the sum for each column. Similarly, along column axis means go from the first column element to the end of the column element and find the sum. So we will get a sum for each row. So let us use axis 0 to find the sum of each column. To cross-check this data, let us extract the first column using indexing and apply sum to find the sum of all the elements of the first column of that two-dimensional array. So let us extract the first column. Here is the first column, and let us apply sum on this first column. So we got minus 0.76574 minus 0.76574. So we got the expected result for axis is equal to 0. Similarly, the sum along the column axis, that is the sum in each row. To find the cumulative sum of the array, NumPy provides cumulative sum method. Let me create an array to show this, and then apply the cumulative sum to find the cumulative sum of the one-dimensional array. So the cumulative sum means 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 2 is 3, and then 3 plus 3 is 6, and then 6 plus 4 is 10. To find the standard deviation, use standard deviation method, that is values.std, stands for the standard deviation. To find the cumulative sum of all the elements along the row or column, we can use the cumulative sum along with the axis control parameters. Let us create an array to show this. To find the cumulative sum along the row axis, that is for each column, use axis is equal to 0. So we got the cumulative sum along the rows, that is for each column. Similarly, to find the cumulative sum for each row or along the column axis, use axis is equal to 1. So here we got the cumulative sum along the column or for each row. To find the cumulative product, similar to like the cumulative sum of each column or row of the array, we can use the NumPy's cumulative product method. Here I would like to find the cumulative product of each row, that is along the column axis. Similarly, you can work with the multidimensional arrays and practice well. Thanks for watching this tutorial. I recommend you to continue learning through the series of training videos. Hi, welcome to this training video on methods applied to Boolean arrays. We know that Boolean methods are used to refer the true or false logical statements with 1 or 0 respectively. So using methods on these Boolean array will count the number of true or false conditions in the preceding arrays. To illustrate this, let us create an array with a range of 10 values. Now let us find the Boolean array where all the elements of the above array are less than 5, that is data less than 5. Here is the Boolean array with true and false statements. Now let us count the sum of all the Boolean array elements where the condition is true using the sum method. If you look at the Boolean array, there are 5 true statements. So let us apply sum. Now to find the sum of all the elements which are less than 5, first we need to create the Boolean array with a logical condition to filter the data elements less than 5. And then use this Boolean condition in the indexing method to extract all the elements of the array where the Boolean array elements are true, and then apply sum to that array, that is data inside the indexing method or the Boolean array condition, and then apply the sum onto it. To check whether all the elements of the Boolean array are true or false, in other words, any test is whether one or more values in an array is true, while all checks if every value is true. For example, let us have a Boolean array to check this. In the above array, we have all the false statements except one true statement. So let us use any method to check whether one or more values in an array is true, that is boolean_values.any. Suppose if the array has all the false statements, the any method will return false. Now apply all method on the first array to see what it returns. We got false. If we apply it on the second array, once again we will get false because all the statements are false in the second array. Finally, let us create an Boolean array of all the true statements and apply all method on it. We got true because the Boolean array has all the true statements. This is very helpful to check whether ones and zeros are present in an one-dimensional very large array or in an multi-dimensional array elements. Thanks for watching this training video. I recommend you to continue with the series of training videos. Hi, welcome to this training video on sorting. Sorting is an important technique which allows us to sort the unique elements and filter the array. Similar to like Python's sort method, we can use NumPy's sort method to sort the array in place. So let me create an array to illustrate this. If we sort the above array using the sort method, we won't get the new array of sorted. In order to see the sorted array, we need to recall it. Whereas the np.sort method will return the sorted copy of an array. That is np.sort inside the parentheses use the data. So it returns a sorted copy of an array. Whereas the earlier sort an array in place. It is referred to numpy.sort. We got the sorted array. So if we want to weave the sorted array, use np.sort instead of the sort method. We can also sort the arrays along a particular axis if we have a multi-dimensional array. Say for example, here is the multi-dimensional array. Let us sort along the column axis, that is, sort the array elements in each row. Here the first parameter is axis is equal to -1 by default. We know that this type of sort is in place. So let us sort the above sorted array now along the row axis using axis is equal to 0. Now the array has been sorted for each column instead of row. Thanks for watching this training video. I recommend you to continue learning with a series of training videos. Hi, welcome to this training video on unique and set logic in NumPy. Unique and set logic methods allow us to filter the data and so set operation on the NumPy arrays. For one-dimensional ND arrays, the basic set operation np.unique return the sorted unique values in an array. Let us create an array of weeks to show how these methods work. Now apply np.unique method to see the unique elements of the array. It returns the unique array. We got all the unique elements of the array, but we can also get the same unique elements using the set method, but it returns a set of unique elements but not the array. If we check the type of the array using the type method for the set, we will get the type set. To sort the elements, use sorted method. It returns a list of sorted elements, that is set. Onto this, apply sorted. Here, the days are sorted alphabetically, not on weekdays. Another function, np.in1d, tests membership of the values in one array in another, returning a Boolean array. That is, np.in one-dimensional array will check the membership of the values in one array with respect to the another array. Let me create an array to illustrate this. Now, using np.in one-dimensional method, check the relationship of the above array, that is the first array, with the list of another array, that is the second array. Values array will be checked with the another array of elements 2, 3, 6. Here, the values array are checked with the another array 2, 3, 6. So 6 is present in the test array 2, 3, 6, hence true. 0 is not present in the test array, so false. 3 is present, true. 2 is present, true. And 5 is not present, so false. To know how set operations in NumPy works, let me create two arrays of type integer. np.intersect one-dimensional method will return the common elements in x and y, and the result is sorted. That is, enp.intersect one-dimensional arrays. Inside the parentheses, pause the two arrays. enp.union one-dimensional method returns the union of elements, and the result is sorted. The np.in one-dimensional method computes a Boolean array indicating whether each element of x is contained in y. Only 3 and 4 of x are in y. So, for the last two integers of x, we got true. np.setDifference one-dimensional array method will return a set of elements in x that are not in y. Here, 0, 1, 2 are present in x but not in y. np.setXOR one-dimensional method returns set difference, that is symmetric differences. That means the elements that are in either of the arrays but not in both. Thanks for watching this training video. I recommend you to continue learning with the series of training videos. Hi, welcome to this training video on how to save and load in NumPy. NumPy is able to save and load data to and from disk either in text or binary format. In this section, we only discuss NumPy's built-in binary format, since most users will prefer pandas and other tools for loading text or tabular data. Arrays are saved by default in an uncompressed raw binary format with the file extension .npy. Let us create an array of elements to show how save and load works in NumPy, and save the array using np.save method. The first parameter is used to name the array, similar to like saving the file in folder with new name. The second parameter is the original array name, that is data. And the file is saved locally in the current directory with the .npy extension. This extension helps us to determine that the file is NumPy array or NumPy file. Let us run the cell. Let us look at the file in our local directory. Here is the saved data or saved NumPy file, that is array_data.npy. To open the array or load the array back from the saved file, use np.load method of NumPy. If the file does not end with the .npy extension, use it at the end of the file. To save multiple arrays in an uncompressed archive, use np.savez and pass the arrays as keyword arguments. To show this, let me create two arrays, that is x and y. Now use np.saveg method with the file name arrays underscore x and y dot npz and names as the keyword arguments, that is array name x and array name y as the keyword arguments with a is equal to x and b is equal to y. Now to open or load the array, use np.load method. It will load the individual arrays lazily. Then we can access the arrays like dictionary keys. Let us load the array bank and then access the arrays individually. To access the arrays individually, pass the dictionary keys used to save the individual arrays. For example, we use the dictionary name A for X and B for Y. So use this name convention to open the arrays. So let us open the array X with the dictionary key A. And similarly, the array Y with the name B. To compress the data well and to reduce the size of the saved file, we can use saveg underscore compressed method instead of just saveg. So let us compress the arrays x and y using np.saveg underscore compressed method, similar to like the saveg, and then load the individual arrays in the same way as we did for saveg. Thanks for watching this tutorial. I recommend you to continue learning with the series of training videos. Hi, welcome to this training video on linear algebra in NumPy. Linear algebra is also an important part of any array library or matrix-like objects. Here, the NumPy arrays behaves like matrix of different dimensions. So, let me explain the concept of linear algebra by creating two different shapes of arrays. Array X is of dimension 3 x 3 and array Y of dimension 3 x 2. To multiply these two arrays like matrix, we need to use dot product instead of star, which is used to multiply the arrays of same shape element wise. But the dot product method is especially used for the matrix type multiplication. So let us use np.dot. It uses the parameters a, b. That means the dot product of two arrays like array A and array B. So we are using X and Y arrays to perform a dot product. Here is the dot product. Alternatively, we can use the dot product like an attribute method, that is X dot dot Y. It is like A dot dot B, dot product of two arrays. Keep in mind that to multiply two arrays with the dot product, the arrays must obey the rules of matrix multiplication. That is, the columns of the first array must match the rows of the second array. Let us see what happens if we pass the arrays in reverse order. That is, first the array Y and then X. We got an value error. Shapes 3, 2 and 3, 3 not aligned. That means the shapes are not acceptable to do a dot product. But if we match the second array with a single column with rows equal to the first array, we can perform a dot product. So let me create an array of single column with 3 rows. So G is an array of single column with 3 rows. Let me check the shape of the array X. It is 3 x 3. The number of columns in X is equal to the number of rows in G. So we can perform a dot product. The at symbol also works as an implicit operator that performs matrix multiplication. So X at Y. To find the inverse, determinant and the eigenvalues and eigenmatrix of the square matrix, we need to import the operations from the NumPy's linear algebra. So let us import the inverse, determinant and eigenfunctions from the NumPy's linear algebra module. That is NumPy.linearAlgebra import inverse, determinant and eigenfunctions. Use inverse function to find the inverse of the array. Use determinant to find the determinant of the array. Use eigen function to find the eigenvalues and the eigenmatrix of the array. The first array shows the eigenvalues and the second array, that is two-dimensional array, shows the eigenmatrix. Similarly, you can work with the other operations of linear algebra on multi-dimensional arrays and practice well. Thanks for watching this training video. I recommend you to continue learning with the series of training videos.